Welcome back, boys and girls. Today we're going to be talking about synchronization, specifically comparing queues and semaphores. Some people, they don't know how to synchronize at all, so they go and learn semaphores, and because semaphores solve their problem, they use semaphores for everything. In this video, I'm going to try to highlight a problem where semaphores are not that efficient, and perhaps what you want to do is you actually want to choose queues. Just to highlight, this isn't going to be a distributed scenario, although because we're doing asynchronous programming, as long as your abstractions over semaphores and queues are correct, this can effectively be distributed as well, and it wouldn't matter. Don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to leave them in the comment section. I have a C# course that is out. If you would like to know C# as I did, highly recommend you take a look at it. With that, let's go ahead and get started. So we have the two solutions here. In both program CSs, currently we have a identical solution. So the problem here that we have is we're driving to Disneyland, okay? And we're gonna start with semaphores because that's the approach I think most people are familiar with. We have the driving to Disneyland context where we are creating the driver and the road and the passenger. So the road, what it can do is effectively alert the driver that some kind of danger is occurring, right? So a truck is passing by, the cat is on the road, the sun is shining in my eye. See, I started recording a little bit later in the day, so I'm not suffering from that problem today. Anyway, on a loop, we are alerting the driver, and the driver is driving to Disneyland and can accept this alert. And it takes some time to process it, right? There is a truck, it's like, whoa, so let me just, wait for it to pass, etc. And otherwise, while we're trying to process the danger, the passenger in the backseat may have a question for us. Like, for example, are we there yet? Can we stop at McDonald's? The standard stuff, the kind of stuff that makes you reach in your hand behind your seat and be like, anyway. While we are processing the danger, we cannot, respond to the question. And the response to the question isn't necessarily that important. The important thing here is that all of these things are happening simultaneously. So the alerts are coming in at the same time as the questions are. So if I run this simulation currently, I have a cancellation token at the top here. We instantiate the context and then we run the simulation. If I open up the terminal, let's take the semaphore solution and I run. I also have a little bit of color coding here. So for example, we're paying attention to the drunk driver, a question comes in and we start answering the question. If we start answering the question, we effectively stop paying attention to the drunk driver, at which point we effectively explode. So this is where we want to bring in synchronization, and hopefully you take this as a hypothetical scenario. As it is, this is meant to represent things like, for example, you reading a file while saving a file, and you want to be able to save the file or update the file, and while you're updating or writing the file, you're not reading it. So you're synchronizing that context, or you're reading the old version. Basically, as long as you understand asynchronous programming and the problems that can occur, you understand what this example represents. We effectively don't want to be answering a question while there is some kind of danger. So the solution with a semaphore is super simple. You literally bring in a semaphore that looks something like this. So private semaphore slim, you introduce a busy flag, as you say new, and you can only process one thing at a time. Now, during the alert of the danger, we're just gonna wait async on this, and we're gonna talk a little bit about the side effects here, and at the end, we will release. So for the duration of the danger, the driver can't pay attention to anything else. Another danger or the passenger. Well, the passenger can still ask a question, and this doesn't necessarily prevent the passenger from asking a question. But if we take the semaphore over here and then we take the busy flag and place it over here. Okay, good. So at this point, we have effectively synchronized the driver. He or she cannot pay attention to two things at the same time. It's either responding to the danger or responding to the passenger. And we can also see this effect here. So if I run this application now, after letting it run for a little while, here is basically the result. Danger comes in, we process it, the question comes in, we process it, and then we process the next danger. So now we're synchronized. A couple of caveats to point out here. Every single time we want to add another method here, it will also have to rely on the busy flag. You effectively have to keep putting this here. Now, ignoring, or let's say we will put aside the fact that, okay, we might want to be able to process two dangers at the same time. And while there is at least some kind of danger, we don't want to be responding to the question. That use case, again, the way that you would synchronize this, you can still use a semaphore. But let's put that on the back burner while we go over to the queue solution and see what would this look like for the driver if we would try to synchronize this using queues. Well, we'll create a private. This can be a concurrent queue, or you can use a channel. A channel is effectively queue with semaphores, and that is basically what I'm going to be opting in for. What I want to be sending in the channel is, for now, let's say integers, and I'm going to come up with my own messaging strategy in just a second. Let's say that this is a channel, and this will equal to channel, create unbounded, so we can have as many messages as we want, and we're going to put an integer in there. Depending on what comes into the channel, we want to trigger the appropriate method. So let's come up with an interface. This is going to be a public interface iMessage. We can clean up the braces and then have the individual messages. So public class alert. This is going to be a message, and we can just take the properties for the danger and the duration seconds. I'll even just put it in the constructor over here and actually make this a record, as I think it's just going to make things a little bit simpler. Okay. A semicolon on the end here. I'm going to do the same for ask question, and instead I'm going to prefix my methods over here with process. So process alert, process ask question, and I will just actually accept the payload for the message as well. So alert, you can probably prefix these with messages. Let's go ahead and have this here. We will then extract the danger from the message and the duration seconds as well, and do the same for the ask question. So first of all, let's replace the properties with the question. Then we're going to have our question. We're going to be processing the question message, and place that over here as well. Cool. So we have our messaging formats. We have our methods that are going to process these messages. Now we effectively need a listening loop. So public, let's say task, listen. We'll say that this is while true, and we have the cancellation token on here. While the cancellation is not requested, let's go to the channel. I'm not sure how these ended up over here. We're going to go to the reader, and we're going to read async. We're going to read one message at a time. Okay. Var message, and I know I'm reading integers over here now. Instead, I will just read iMessages. Okay. And the implementation is really simple. What you have is effectively now just a bunch of if statements where you can say, well, if message is a alert, you're going to go ahead and process the alert. Okay. And however you want to handle the response as well. So let's go ahead and duplicate this. We're going to check for ask question, and then process the question. So process ask question, and there we have it. Now that we're capable of listening, we will have to effectively start that task where the driver is now actively listening for either dangers or passenger queries to happen. So we're going to go to the driver, and we're going to start listening, and this is just going to be part of the whole thing. All right. The passenger and the road can no longer just submit messages like that. In fact, these two methods are going to be private now. The message formats can remain public because that's effectively how we're going to be communicating over here. Another thing that will need to happen is we will need to submit messages to this channel. So we will have, I think it's a value task. We'll just have a send, some kind of type. This is going to be a type of message. So where t, too many colons, is iMessage. And a really simple implementation where we go to the channel, we go to the writer, and we just write async, and we write the message. Okay. Now, if we go to the road, what we're going to be sending to the driver is going to be a new alert, and the alert will be present on here. So driver alert, one more parentheses on the end, probably indent this, will look a little bit better. I'll copy this line over here. Let's go down to where we have the passenger. Let's actually do the same over here. So new ask question, this is going to be driver ask question, one more parentheses over here. And the important thing here is this is currently erroring because we can't have the answer. So this is a caveat with the messaging approach, where if you're taking the messaging approach, you're either going to have to use messages everywhere, or I'm going to show you an approach that you can use as well. So now that that is done, what we have effectively achieved is the driver is going to constantly listen for messages, and depending on which message came in, it is going to process that message. And by the way, we probably want an else if over here. Okay, so if we come over to the queues, let's go ahead and clear that terminal. I'll run this. And after running this for a while, here you can see a slightly different effect. The individual steps are synchronized because we receive a message, we process it, and then we read the next message. So effectively, requests from various incoming messages are synchronized this way. However, because the other objects, which are the passenger and the road, are no longer constrained to waiting because of the semaphore to resume their task, you effectively get more asynchrony between those objects. Those objects are not sitting around there waiting for each other. Before I get into the detail of covering some caveats, let's just get this out of the way. Why would you use one approach over the other? When would you use a semaphore over queues? Okay, so semaphore, you have a code block. You want to restrict access to this code block. You put a semaphore over here and over here. You effectively check how many tasks, processes, threads, well, not really processes. If they're completely different processes, you need mutexes. Ignoring that detail, you have a code block, you want access to this code block in a synchronized manner, you use semaphores. You effectively have gates, okay? With queues, it's a slightly different story where the synchronization is really, well, because the messages are in order and because you're only capable of processing them in order, you're going to get synchronization that way. And the way that you use queues properly is once you have a bunch of objects, same as the driver, it has an internal queue of messages where you will be processing it, right? If you have objects communicating with each other, they're all sending messages to each other to their internal queues for whatever processes are happening. There isn't some kind of shared queue on the side over here. There's a queue right over here in the middle, okay? And then the synchronization happens inside the object. And if you're familiar with the actor model, this is basically on the step there. However, you just don't have that distributed scenario covered here. You would effectively have to have your own peer-to-peer model, but I just wanted to show you how you can have this in-memory actor model thing available over here. All right, it's not that hard to build up. Now, the big symptom for when you're using semaphores, and you should actually be using queues, is as soon as you get something like this, busy 1, busy 2, I'm doing A, therefore I can't do X, and while I'm doing Y, I can't do Z. Once you have many of those conditions, once you have more than one semaphore, what you really want is queues. Now with queues, if you have your passenger, let's say right over here, and we actually want our answer to the question, you have an option of embedding awaits into your messages. It is not ideal. You want to effectively go full into queues, but perhaps what might happen is you have a request coming in. The way that you interact with some of these objects is through messages. You send in a message and you want to wait for that message to complete. At this point, you effectively want to add some kind of acknowledgement to the message. So let's go over to the message format over here. And right below the message over here, we will create an abstract class. And it's not going to be an iMessage, it's going to be an awaitable message. And we're going to use promises to simulate that request response. We will be able to return some kind of payload, so t return. On here, you would put a message, or sorry, not a message, a method that would effectively acknowledge the message and submit the return. So private task completion source. If you don't know, this is a C# promise. You put t return on here. We'll say that this is a completion. We'll say that this is a resolve using the JavaScript notation here. And I'm just going to say that this is new. Okay. You're going to have a public task of t return. This is going to be the result. And all you're doing here is on the result, you will have the task. Okay. If you want to complete the task, you would have a void complete, put the t return over here. This is going to be your result. And on the resolve, you would have your set result, and you're done. Okay. Now, if, for example, ask question is going to be an awaitable message, and let's say this is actually an abstract record, why not? And what we're going to return here is a string as well. Once we have this, when we're constructing our message, so let's say var message, we're going to send the message. This is now a little bit smaller, okay? And on the message, we can go ahead and await on the result, okay? So var answer, await. Coming back around to where we process ask question, instead of returning this, we now no longer return this, okay? The pfte, we actually want to go ahead and go to the individual question. We want to complete it and send the result this way, okay? Whether you do it here or return the result and do it in the loop, again, this is a decision that you should make yourself. I'm showing you just how to get around some of these problems. If you don't want to go full objects with queues and you still want to have that request response and wait for the response, you can do it this way. And yeah, most of the time you should still be using semaphores for synchronization. Only when you are in that complicated many objects communicating with each other, put queues inside of them, make them process their messages asynchronously. Don't try to say, okay, while we're processing this message, we cannot do that. And while we're processing that other message, we cannot do this other thing. Queues will massively simplify this problem. And again, the main symptom is once you have multiple semaphores to check for multiple conditions, if you have some kind of enum to check the state of an object, whether you can do one thing or another, and you just have one semaphore to synchronize the change of the state, you still have the same problem where you would rather be using queues. Okay, so thank you very much for watching. Hopefully you enjoyed this video. Don't forget to leave a like and subscribe if you did. If you have any questions, make sure to leave them in the comment section. If you would like the source code for this video as well as my other videos, please come support me on Patreon. I will really appreciate it, and a very big and special thank you goes out to all of my current Patreon supporters. You help me make these videos. As always, thank you for watching. Have a good day.